Hello hackers, welcome back to Rust for Hacker series. This is going to be the 13th project in the series, and today we are going to develop a tool, a custom tool for shellcode encryption. We will be trying to implement it using XOR, and the next part of this same encryption series, we will be adding more encryption options into that, like AES, and we'll try other encryption options too. But for this video, I'll be implementing XOR. Then we start with XORing, then how we try how to convert our shell code by applying XORing. Then later we try to implement in a shell code runner to run the actual shell code and how to check it how it works or not. Then move to the XORing. It's a byte load operation, and yeah, it works with any type of files. Basically, it's repeating the key. Key in the sense, in some of the malwares, when they XORing, they normally use single byte keys, but here we are going to use long keys because the encryption option basically it just repeat the keys based on the content of what we are giving as input. And the main part is its symmetry, means the same function uses for encryption and decryption, because it's just a byte flip. So and you should know how it works, like the bit operation or the byte operation, how it works. The basic operation looks like this. Suppose if you do this this byte with this key, and the result will be this. Then again, if you try to do the encrypted part with the same key, you will get the plain text. So that's why it's called symmetry. Then the main important thing you have to know before doing this one is how the XORing bit operation works. It is very simple. If its bits are opposite, like 1 or 0, it gives 0. Like if it's 0 XOR 1, like this, you consider this first bit of this one is 0 and this is 0, and the result is always 0. So if the bits are same, like 0 or 1, the result will be always 0. Even for 1, XOR 1 will be always 0. The only case it returns 1 is either of the bits should be 1 and the other bits should be 0. It's very simple. Like if the bits are same, it returns 0, else it returns 1. So that's basically the operation that happens behind the scene. Before moving to the shell code, we try to start our project and start implementing how we can achieve the actual encryption using XOR. Let's start. What we can say, go new XORing something, cd XORing, then just opening editor. Is in a normal case we don't need any kind of external libraries for this one, but let's see how it's going to work. So for this one, we say let plain text equal to hello hackers, and let key equal to okay, as it suggests secret. Then say ciphertext equal to encrypt and decrypt, or it suggests so many things. We are just taking that, and here we are going to say encrypt plain text as string. Okay, to do, it says to do, it doesn't know what we are going to do. So what I'm thinking is, because since it's going to be byte operation, so I would like to do this as a byte slice instead of string, and key as same, make it as byte slice, then return same same bytes as vector. That will be easy to process when it comes to shell codes. So here is the main operation that we are going to do. What we can do here is, when we save this will show. Anyway, we didn't decrypted it, so, and here just because it's XORing, encryption and decryption will be same, like the same operation is going to work for both. So, and here it is showing error because the parameters slice, byte slice, so we can convert this to as bytes, and key also convert to byte slice. So now the error in encryption will be gone. So the next, decrypting will come to that later. Before that, we have to do our actual encryption option here. Then come here. So let's try, say, oh yeah, it suggested that result. Okay, that's a good suggestion. Let's result can be mutable vector, and the next thing is just say for I'm going to do a normal loop. So I then in 0 to end of it, plain text. This is actually the real operation. Like if you want to do it very clearly, like if you want to make it more readable, actually this is the same thing that we have to achieve, but like if you're going to do this first time in Rust, it's always better to make it clear. So what we have to do is we have to fetch the key byte first, like the same operation the AI suggested, key byte equal to so key and the I mode key length means we are just basically going to iterate every time till the key, suppose the key has 3 bytes, then it takes from, when it comes to 0 mode, key length is, suppose 0 mode 3 is going to return 0. So first iteration it will take the first byte, then second iteration 1 mode 3 is again it returns 1. So like that it goes. So we ensure that we cover every bytes of the keys. So once the key bytes is over, again it starts iterating from the beginning. So we just ensure that every part of the plain text is encrypted with every part of the key bytes. So as a next operation, we take this is a good suggestion, plain text, and encrypted byte is going to be plain text byte XOR this one. Then we push the result here. We push the result to the vector, because it's a mutable vector, it's fine. So we are returning the result here. So it's done. Basically the XORing is done. So just want to test it. So hello hackers, this one, and we encrypted this, and the plain text is this, and the ciphertext. For the ciphertext, since it's returned a vector, I think there is a function called string ut from ut of 8. I think this one accepts a vector, so we can say ciphertext, I don't know, this will work. Is there any toString option? Why it is always saying this one? Oh, there is another function actually. Yeah, this one is better for us because this one returns why it is showing error. Number that is string found on. Okay, I think it's better to take this here and let cipher string equal to, oh yeah, so this one is returning slice of bytes to string including invalid characters. Okay, so if you want to print this, let me see how it works. Is it okay to print it like this? Yeah, it prints that. It's fine. So we just try to convert the vector to a string just to try to print the encrypted characters. So the decryption works in the same way. So since it's a vector, we need to pass the same or we need to pass a cipher. Let's try this one. I don't know whether it's going to work here. Cipher string and bytes, and let the decrypted, we need one more. Okay, here it should be again as bytes. Then the next one will be let decrypted string oh yeah, hopefully it will work. I am not sure. I have doubt on this part. Like, okay, let's try this. Cargo build. Okay, cargo, try cargo run. Oops. Oh yeah, it worked. See, the plain text was hello hackers and ciphertext is, yeah, of course, non-printable characters. Then again we did call the same encrypt function once again to decrypt the ciphertext. That's what I was mentioning here. It's called symmetry. If you apply the same key on the ciphertext, you will get the plain text. That's how it works. So our basic skeleton function is working. Next thing we need is we have to take the shellcode as shellcode inside this application, and then we have to convert that shellcode to an encrypted shellcode. Then try that encrypt the shellcode in a shellcode runner. I have a shellcode runner template. Actually, I plan to share that at the time of when we start the malware development using Rust. But anyway, I can share that now. So we will try that to ensure that the shellcode is running. So before that, you should know what exactly a shellcode is. It's nothing but, if you are into security, you already know that it's a small piece of machine code instruction. Actually, it's a binary hexadecimal opcodes. Normally, it is designed to be injected into a running process and executed directly by the CPU. So it could be anything. It totally depends upon what kind of shellcode you are generating, and there are so many tools that will help you to generate shellcode. You don't need to do it manually, but if you are interested, definitely you can. But there are tools like Metasploit. Here I'm going to try Metasploit to generate shellcode. Then we try to run that shellcode to supply the shellcode here inside the app. Then we use our same shell encryption algorithm just to ensure that the shellcode is decrypting properly and running on the machine. Here, for testing purpose, I'm going to create a shellcode for Linux itself. So the tool I'm going to use is msfvenom, and we will be trying I think it's Linux, because my machine is 64-bit, and it's going to be shell TCP. This is like don't worry about the path I'm using, because if you're using it first time, it may be very strange to you, but if you're using it regularly, you know what those path means. It's nothing but I'm exclusively saying msfvenom to generate a shellcode for me that should work in Linux x64 based applications, x64-bit operating system, and that should be a shell, and that shell should be a reverse TCP. That means whenever this app if I'm going to make I can generate different variety of formats using msfvenom. If you are trying to generate a binary that's going to be run on the target, this when it's going to run by the target, it will get connect back to the attacker. Here I'm going to generate a shellcode, not a binary. So just ensure that IP, we are supplying the right address here. This is I'm going to use the same machine as my attacker and victim machine. Just is for demo purpose, so it's fine. So we need to set up the L host for this and just say L port 8081. Just for the sake of testing, I'm doing this one. If it's going to be a real time, just try to use some known suspicious ports. And the shellcode I want to be in Rust format. So if everything is correct, that all the parameters that we supplied are correct, we will be getting, we got it. So this is going to be this is actual shellcode. It's a raw bytes in hexadecimal format. This is going to be directly executed by the the actual target. So there are some challenges for us, like we need to convert this if you're trying to make an application that directly reads input from the keyboard, so it may not be suitable, because I don't know whether our terminal will be allowing us to enter this shellcode as an input to our application. So what will be the best way is we can mention a file name inside your application, and you can read from the file. So I think that will be a better way, because when I was trying even for the other applications, there are some limitations on the terminal for entering these kind of shell codes. So what I'm planning to do is we can try writing this to a file, and later we can read from it. So what I'm going to do is just this will be the folder, just for the sake of build. Oh, we didn't do anything here. Okay, inside the build we can try a new file, just say shell.txt or something, and just paste it here. So let it be here. And now what I'm planning to do is, instead of the hello hackers here, we will read it from from the file that we just supplied. For that we need use some packages. I think it is use std .io fs file, yeah, and fs file with other options. So we may need just for the sake with this one I'm going to use io read and io write. Yeah, just if you don't want to do the io write, we will remove it, but yeah, just keep it there. Oh, sorry, this one should be io read and write in the std, so we have to mention it like this. Think so, yeah. So next thing is we have to read from the file. So just say read content, file name. Here while we are reading, I think it's always better to read it and return it as a string, because that will be the easiest thing that we can do. And when we are returning while with the read operations, file operations, it's always good to return with the result type. What I'm saying, result, if it's going to be a successful scenario, it is going to return a string as a content, or it's going to return error if in case of error. So this one we already did when we did the second project. If you have some doubt on that, you can try refer to that. The code is already there. So what we can do is we can just say we need a string, just say content, then we need to read the file. We don't need to assign the variable, we can directly use the open path. Yeah, I have explained all these things in the log analysis part of the project and second project. If you haven't seen that, I strongly refer to go and watch that. You will get clarity on what exactly we are doing here. Yeah, the question mark is just expanding the result type. If this is a successful one, it will go to read string and it reads the string. Then again we are just saying question mark, because if the read is successful, we will be returning the content. Else, whenever the question mark is trying to expand, it will, if it's an error, it's going to return an error. You don't need to explicitly mention that here. So now we read the content. So instead of this one, what we can do is we read the content from the file. Okay, so what we can do is read content. Instead of the path, I'm just saying what is the shell.txt. Yeah, it is unwrap. Yeah, because it's a result type. And just say it's encrypt. Oh, say the next challenge we have is, it was easy to convert the normal string to plain text and taking it back, but here when if we check this one, the shellcode that we got has this format: 0x, then the actual opcode. So because it's a hexadecimal format, so we may need to parse this. For parsing it again, we need okay, we read it from, instead of this plain text, I'm going to say it's shellcode. This is actual shellcode inside. So the shellcode is in string format. Now we read the content, and actually in core runtime, I'm a real-time production use, it's always recommended to handle this result properly using the match or using unwrap or else something, and then try to do the error print. Here for testing purpose, I'm just directly assigning it. For now we read the file content. After the file content, we need to parse the content by sending it to another function, because we have to the format that we have is something weird. What I'm planning to do is converting this to a sequence of bytes. Basically, is going to just like the other one, we have to convert this to normal byte size byte vector. For that, what we have to do is we have to remove this part and take this content, and then convert that to a byte, a normal byte, from this hexadecimal code to byte, so that it will be easy for us to process. For that, we had to just say a function parse shellcode or something, shellcode. So yeah, accept this shellcode as a string of slice and return the result as this one. So we are not going to convert this again. This byte conversion will not sufficient, because we need to remove the 0x, then we take that the other two parts, then convert that to byte. It's going to be basically bytes of vector. So for that, what you have to do is, let's say here also just say let mute result a new vector, and let shell, let's say shell splits. We have to split the shell code based on the comma. Yeah, because it's comma separated, we are going to use the comma as separator for splitting it. So this will give another slice of string. Then we have to iterate, like for say for every shell byte in the shell splits. Oh yeah, actually this is going to be the function we need. We have to convert the 16-bit hexadecimal from the hexadecimal to byte. Okay, for that I'm just keeping it here. It did get what we want, but this is not going to be the right way to do this. This is a function we need, in fact, but we will take this as a last step because we have to remove the 0x from that. For that I'm just saying we can trim, just say the trimmed shell byte. Yeah, the trimmed shell byte is going to be shell byte or trim is going to remove, if in case of, just for the safety check we are just removing everything, because shellcode is very sensitive, we don't mess it up, so we just remove every possible spaces from that. Then now we need to clean this up, like we want to remove the now we have the slice of string as like the first string, like 0x31. Now we need to clean this up. For cleaning it up, let's say less cleaned byte or something, I don't know. Yeah, just say clean byte. I think we can do the if check here. If the trimmed bytes trimmed byte dot start with this a function. Yeah, we start with what is 0x, right? Yeah, 0x. Let's just confirm it's 0. Yeah, if it starts with 0x, then what we do, we take the first, we skip the first two. Yeah, this is correct. If it's going to start with 0x, we skip the first two. Yeah, for the safety check we say if it's not going to be start with 0x, we take whatever it is. Like this case, in logical way, it will not come in normal case because almost all the byte codes, I mean the shell codes, will start with, every hexadecimal code is going to be start with 0x when it's generated by Metasploit. So now we have this one. So is any issue on this one? No, I think now this is okay. And the next thing, now we have the trimmed one. The next thing we need is this operation, in fact, but we have to perform this operation not on the shell byte but on the cleaned byte, because the cleaned byte now will have the actual 0x removed hexadecimal code. So what here happens is this function will convert the hexadecimal code to a U8. So it's going to be a byte, normal byte, then equivalent to the converting the hexadecimal code to a byte, normal byte. That's what is happening here. I have used this function before on the other projects, previous projects, so you just try to go through that. So this should be assigned, what to say, yeah, the actual byte, in fact, the final byte. So let it be, oh, this should be a semicolon, no, oh, okay, this doesn't need that. Why it is showing error here? Oh, the semicolon should come here. Oops. Okay, maybe it is because we are not returning anything from, yeah, this, we just return this, and what is the result? Maybe this is correct, yeah. The Rust C analyzer shows so much of errors when we miss out some small things like this. Here it was showing error because we were not returning anything, so that's why it was showing so much of red lines. So what happens here is the clean byte will have the actual hexadecimal code. From this one, if you consider this 31 0x31, we are just taking only 31, and again we convert the clean byte from hexadecimal format to a byte format, like converting to normal bytes. So that's what happens here. Now we have the actual byte, not the hexadecimal but the normal byte, equivalent bytes. So now we pass the shell code. The next thing is after passing the shell code, we try the actual encryption. Now we have the, just like the previous case, we have, what to say, the previous case we were directly supplying the plain text from here. Now we read the content here, and the secret is at the same. Then yeah, let plain text equal to pass shellcode, and that is our shellcode. Yeah, this is going to be a vector. So what was our encryption function was, it was a slice of text. So this will what happened here, I just lost completely. Okay, come back to this. This is passing the shell code. We just removed the 0x and converted the hexadecimal to normal byte. Then we need to pass that to our XOR encryption. So yeah, we can, okay, we don't need to do this one. Instead of, we can directly pass the plain text here. Actually it is not plain text, it's a, we can say pass shell code. We pass this here, and yeah, key. Okay, I'm just converting this here itself, so we can directly pass to say the reference to that. Yeah, now we encrypt the text. We encrypt the shellcode. Now we need the shellcode to be printed, and we have to pass the same kind of shellcode to we need to keep the same format. Even though we did the operation on the normal bytes, it should be like when we are trying to create it, we have to print it using the 0x format itself, because that format should be kept for when we try to run it in memory using the shellcode injector. So for that, okay, just for getting that printing that shellcode to the console, we may need, because we are getting a vector again, what we can do is just say instead of ciphertext we can say encrypted shellcode or something. That will be better. Encrypted shellcode is this, and now we need to print this. For that, what I can say is, okay, let's select shell code string. Yeah, not this way. We have to print it on the same way with the 0x format, so from the vector itself. So just say encode shell. Oh, what is this? Oh my god, this suggestion is too much from this one. But what we can, okay, I think it's suggesting the correct format. Oh yeah, it is correct. Okay, let me take this. Oh, it suggested too much of things. After this, what is this? I don't want this one. This is shellcode string. We have to iterate over it, and map is a function that we already explained on the previous videos. It's basically nothing but it just take every members from the vector and perform some operation based on what we say here. In here, what we do is we just format it, but this format is wrong, I think. Yeah, we need the 0x format. For that, oops, 0x, this, and this should come here. I think so. This will work. 0x and 0 to x. This will work. Did I miss something? No, it should be here. The format string is really weird. Yeah, you just go through these things, like these are very basic. I forgot how it should be. It is a very basic thing when we are trying to print something. I think this will work. It will convert the 0x and then the hexadecimal format from using every byte from the encoded byte array, encoded vector that we got after the encryption. Then it separate, it joins the entire thing because the format is returning a string, so it joins everything using the comma. So normally this should be working, and I'm just removing this. Okay, I'm just and we don't need this one now, and of course we are not doing the decryption now. Let's print this. Okay, also we don't need let's try this one. Cargo build generated a warning and cargo. Okay, we didn't use the right. Okay, what was the result? Where it came from? I don't know. Oh, sorry, one more. Let's try. Okay, right is not in use. We will remove that. For testing this, we just move to target debug, because there we have the where was the did we kept it under target debug? Okay, it's under build, so take it back to debug folder. Yeah, now it is under debug folder. So now we have the actual shellcode in debug folder, and I'm going to run this. XOR. Yeah, it applied something and we got something. I'm not sure it's going to be. It is a correct one. For testing this, what we need to do is we have to. Okay, let me replace the content in shellcode, and we need to ensure that we get this back. Yeah, now we go to the single line. It's good anyway. So we build it again, just for the testing purpose. Okay, just want to ensure that we are getting. So we did apply the XOR again on the encrypted. This was the encrypted shellcode, and we applied the XOR again on the same encrypted shellcode, and this was the actual shellcode from the msfvenom, and this is the equivalent, the shellcode that we generated after the encryption. So basically it is same. See, 031ff 031ff and x6a 0958. Okay, so this is working perfectly. So now we ensure that the encryption and decryption shellcode is working with perfect formatting. Now what we have to do is we have to test it in our shellcode runner. So it's going to be Linux shellcode runner, and I have the template with me. Let me open terminal here. Just say I'm just going to take this source code from my template. I already have. Actually, as I already informed you, I kept it for my malware development series using Rust. But yeah, I'm not going to explain the entire thing in code, but I will show you how it works. Cargo new shell runner or something. cd cargo cd shell runner. Let be here. and my shellcode runner I have is here. This is shellcode runner, and oh yeah, we need for the shellcode, because this shellcode is actually the shellcode, the runner itself has a lot of things to learn, but I'm not going to explain the entire stuff here in this one. When we come to the malware development part, I explain how it works. This one is, how to say, crates. In this we have to go and check the libc, and we need to refer that inside our app. See the dependency like this inside the shellcode runner. Go to cargo.tml and refer this here. Now the rest must be, the error must have gone. Yeah, it's not. Yeah, the error is gone. And here is the basically this shellcode runner has what to say, it is it's a direct character array that is generated from the msfvenom, and it takes that and try to run the shellcode in memory. It is basically using the function pointers. It's nothing but it allocates the memory, then it tries to copy the shellcode to the memory area, then it change the protections to memory protection to executable, then it runs the shellcode for you. That's what it's doing. It is almost like in Windows also there's the same way of running this. For this one, what we have to do, we have to implement the XORing here. So before that we need, okay, now we have this one. I'm going to start my Metasploit to check this payload. For starting the Metasploit, I'm going to take another terminal. Just say msf console. So msf console is getting started. Oh, why is taking too much of time? Yep. So here what you have to do is you have to set up your multi-handler and set your payload as same as the one that we created with the shellcode. So if we check here, there are some options that we need to set, just like the same L port and L host that we set for our shellcode. Set L host 192.168.1.199. Set L port, I think 8081 we set, yeah, and run this behind the scene. So now the Metasploit server is kind of running. It is listening for a connection. So what we have to do now is we copy this shell code. Okay, we already copied this, and where was the other one? We got this. Oh no, this was our encrypted shellcode, right? This was our encrypted shellcode, and you copy this now. Just say, oh, this is not going to be the actual shellcode. So what we can do is we can say, okay, let it be this one. This is going to be the actual shellcode, but we need the encryption function implemented here. So what we have to do is, this was encryption, right? The XORing. So let it be here in our shellcode runner. So this, because this is going to be, XORing is symmetry, it will work, and we copied the encrypted shellcode, so we have to supply the same key. Let's say the key is here. Now we say, okay, before actually going to run this shellcode, we have to ensure that we are getting the actual real decrypted shellcode after this operation. So for that, we try to do the same printing that we did here. Let's say this one, yeah. Let's try this one, and just ensure that we are getting the actual shellcode, encrypted shellcode. Okay, this one. So theoretically, yeah. Where it is. One has, yeah, this is shellcode runner, right? Cargo, just try to do the cargo run. Oh yeah, it has to take, oh yeah, we got it. We got the exact shellcode generated by, this msfvenom, right? Yeah, this is same 0xE8, 0xE8, xE6, E6 is fine. So this one is perfectly working. We got the shellcode. So actually after this, in fact, I don't need to show you how it's going to work, but for the sake of what's going to happen for the shellcode run, I will try to run and show you how it works. So basically the project we did is finished. Like we did the shellcode XORing. See, we have used a key as a secret, but you can make it to anything that you want. So we basically did XORing all the shellcodes. The important things we have to note is when we apply the shell, before applying the XORing, we have to parse the shellcode and take bytes from that, from the hexadecimal format, after removing the 0x format that is given by the msfvenom. So here what I'm going to do is I'm going to try to run this. Now this shellcode is correct. Now we have to ensure that our shellcode is running in the sense we are getting the shell back after executing this in memory. So what was here, we need to make some changes here because the actual shell code, see here it is, this is our encrypted shell code. We can't run that here directly in memory. So for that we have to use our encrypt, because this is going to be our encrypted shell code length, and this one doesn't have any reference to the shell code because it's taking the just allocating the length after this, so there is no reference for our shell code there. And the shell code pointer is this. If it's null, it's failing. Then here is memory copying the shell code to the actual memory. So yeah, here again this is the place we need to change. See, it was shell code. Previously my template had that actual real shell code, no encrypted shell code, but here now we have the encrypted shell code. And the important changes here you note is it was a character, this is byte array, but now we have vector, but it doesn't make any change when we using this function. And now it is, after that we make the change the protection of the memory region to executable, then we run the shell code using the shell code pointer. It's a function pointer. So if everything is fine with this one, now it printed the shell code for us. So now after printing the shell code, it should run this shell code in memory, and we should get the reverse shell back. Where was our listener running? Where was that? Is this one? Okay, I'm just keeping it here. Now the reverse shell is running here, and this is going to be a shell code runner. It's shell code, so I don't have any guarantee that it will work. But after seeing this one, there is no big changes in the shell code after the encryption and decryption, so it should work. So cargo, just try cargo run. Oh yeah, see on the right side it is sending bytes. Sending stage is done. Yeah, we got the shell back. See, the shell code is running. See, it's perfectly running. There was no change after the encryption and decryption because it is the same shell code that we got after the XORing. So where it is useful is when we have some kind of static checking, static binary, static signature checking from your AV products or whatever, scanning your product, scanning your binary for finding out the shellcode signatures. There you can apply this technique, and this is going to be the first part of this. Actually, the shellcoder is shellcode encryptor is not finished. We will be adding AES option also with this one to finish it, because the msfvenom itself has XORing and AES encryption available built in. The next thing, if you are trying to do, is you can try from that. You try to generate an XORing shellcode, XOR shellcode from the msfvenom, then try to implement the same thing here. Here you don't need to change anything. The only thing you need to change is the secret. You just ensure that when msfvenom is going to generate the XORed bytes for you using the secret that you supplied, you have to supply the same secret here and do the same thing here. I'm not sure how, if the msfvenom is basically, there is no, it's a common way of doing it, like XORing, so it should work. You can try that. So that's all for this video. On the next one we continue with the shellcode encryption with AES, then we finish this project. So it's now it's finished for this video, and it's a bye from me. See you with the next video.